Assalamu alaikum and very welcome to this new video on zero sum game. Ladies and gentlemen, in the earlier video I discussed the introduction to and the basics of the game theory. In this video lecture I am going to explain zero sum game. Before I explain this video in detail, let me introduce the background. In the earlier video lectures that we examined the theory of optimal decision making by a single agent firm or consumer in a very simple environment when there was complete or perfect information and certainty. The strategic interactions of the agents were not very complicated in that case when you are discussing the consumer theory and the producer theory. Here, we will lay the foundations for a deeper analysis of the behavior of economic agents in a complicated environment. And this is game theory, which is a systematic study of how rational agents behave in strategic situations or in games where each agent must first know the decision of the other agents before knowing which decision is best for himself or herself. Therefore, game theory is the study of strategic interaction decision making and is thought of as the most appropriate model for most economic behavior. This theory has been widely used in economics in the last 2 or 3 decades, and much progress has been made in clarifying the nature of strategic interaction in economic models. In fact, most economic behavior can be viewed as special cases of game theory, and a sound understanding of game theory is a necessary component of any economist set of analytical tools. That is why game theory is very important, especially in microeconomic theory. There are several ways to describe a game. For our purpose here, the strategic form and the extensive forms will be sufficient. Roughly speaking, the extensive form provides an extended description of a game, while the strategic form provides a reduced summary of a game, which is simpler than the extended description of a game. First, we will describe the strategic form of a game here. The strategic form of the game is defined by exhibiting a set of n players, where n is a set of 1 to up to n players. Each player I has a set of strategies to be chosen from capital SI, from which he or she can choose an action denoted by small si, which is a member of the capital Si. That is, the course of action that he chooses is a set of strategies, and a payoff function phi is that indicate the utility that each player receives if a particular combination S of strategies is chosen, where S is equal to small s1, s2 up to Sn, and these are these are contained in capital S, and that is equal to the product of Si, where I varies from 1 to n. For purposes of exposition, we will treat two-person games in this video. All of the concepts described below can be easily extended to multi-person or n-player games. We assume that the description of the game, the payoffs and the strategies available to the players are common knowledge. I have already explained the 3 basic elements of a game in the previous video, that is video number 471, and there are 3 basic elements: number 1 player, number 2 strategy, and number 3 payoffs. So this should be a common knowledge for now for all of us. So each player knows his own payoffs and strategies and the other player's payoffs and strategies. Furthermore, each player knows that other player knows this, and so on. So both the player knows each other payoffs and strategies. We also assume that each player is fully rational. That is, each player can choose an action that maximizes his utility given his subjective beliefs, and that those beliefs are modified when new information arrives according to Bayes' law. Game theory, by this account, is generalization of standard one-person decision theory. How should a rational expected utility maximizer behave in a situation in which his payoff depends on the choices of another rational expected utility maximizer? That is discussed in game theory. Obviously, each player will have to consider the problem faced by the other player in order to make a sensible choice. We examine the outcome of this sort of consideration in the coming slides. Here we assume that this is a simple game in which there are two players, and we denote these as player 1 and player 2. Each player has a coin which he can arrange so that either the head side or the tail side is face up. And this example in the microeconomic books, textbooks, is known as matching pennies. So there are two players. Each of the players has a coin, and he can arrange it in such a way that either the head side or the tail side is face up. Each player has two strategies, which we abbreviate as heads or tails. It means that either the player has head faced up or tail faced up, and similarly the other player can also do the same. So there are two strategies available to each player. Once the strategies are chosen, there are payoffs to each player which depend on the choices that both players make. These choices are made independently, and neither player knows the other's choice when he makes his own choice. We suppose that if both players shows heads or both shows tails, then player 1 wins $1 and player 2 pays this to player 1, and player 2 loses $1. So if both of them shows heads or both of them show tails, then player 1 is the winner and he is winning $1, and player 2 is the loser. He loses $1. If on the other hand one player shows heads and the other shows tail, then player 2 wins $1 and player 1 is a loser. So in this table, this is a kind of payoffs table. This is game matrix of matching pennies. So we show player 1 here and player 2 column wise, and these are heads and tails for the player 2, and these heads and tails are for the player 1, and these various entries in this box are the payoffs. So if both shows heads, then player 1 wins $1 and player 2 loses $1. So the first entry is for the player 1 and the second entry is for player 2. If both shows tails, then again player 1 wins $1 and player 2 loses $1. And these two strategies, these two entries, when there is when the player 2 shows tail and player 1 shows head, then player 2 wins $1 and player 1 loses $1. Similarly, if player 1 shows tail and player 2 shows head, then in that case again player 2 wins $1 and player 1 loses $1. So these are the various payoffs. We can depict the strategic interaction in a game matrix that we just examined in the previous slide. The entry in box head tails indicate that player 1 gets the player 1 gets -1 and player 2 gets +1 if this particular combination of strategies is chosen. For example, if one show head and the other one show tail, then player 1 loses and player 2 wins. Note that in each entry of this box, the payoff to player 1 is just the negative of the payoff to player 2. This is quite simple, because if player 1 wins, then player 2 loses. Similarly, if player 2 wins, then player 1 if player 2 wins, then player 1 loses. Because the payoffs always sum up to 0, this type of game is called a zero-sum game. The gain of one player equals the loss of the other player. Let me show the previous slide. When player 1 wins, this is the entry for player 1, then the player 2 loses, so this is the -1 is the opposite for this. Similarly, in this entry, the player 1 loses and player 2 wins, so this is the opposite for this. So that is why they say that when one player wins, then the other player loses. So therefore, the payoff always add up to 0, and the gain of one player is the loss of the other player. So in a zero-sum games, the interests of the players are diametrically opposed and are particularly simple to analyze. We may define, therefore, some zero-sum game is a game in which the gain of one player equals to the loss of the other player. So in this kind of game, when the gain of one player is equal to the loss of the other player, we call it zero-sum game. However, most games of interest to economists are not zero-sum games. They may be different than that. So we have some other kind of equilibria like Nash equilibrium, Pleasant dilemma, and so on. So ladies and gentlemen, this was a brief discussion to zero-sum game, which is a very basic video for the beginner. I hope this is informative for you. Kindly subscribe to the channel and don't forget to click on the bell icon so that you can get timely notification about my other videos that will be uploaded for you. Thanks for watching this video. Kindly share this channel and various videos of this channel with your colleagues, with your friends, and with your students. Thank you, and see you in another video.